Okay, welcome here. Hopefully you're not watching this because if you're watching this video, it means that Cami didn't work for you. And so you're going to watch me make the Cami videos because some people weren't happy with just Cami. They're scared of it. So I think it'll work though. Hopefully Cami works. But anyways, I'm just going to start using Cami here. I'm going to do two different screen captures at the same time. All right. Okay, for this question, or this part, I did some of this in class, but I really want to highlight some things that in order to determine how a wave front gets reflected off of a solid barrier, we have to use two things. We need to use, or three things. The angle coming in, so that's theta 1, or I for incident, and the angle of reflection, so that's theta r. I think I did theta 1 and 2 in class. And so theta I is the angle between the incident wave ray and the normal line. So we're going to have to use wave rays here. Remember, this is a wave front, and for a wave ray, we just pick any point. And I like to use the edges. And so say we use this point. It's going to come in straight here. It's moving this way, and it's going to hit the barrier. And then it's going to reflect this particular point, and it's going to come out here. I kind of missed that, but it's supposed to go right to the other corner. Okay? And so that's what the wave ray is going to do. And what we got to highlight is there's this normal line here. Okay? And it's perpendicular. So I draw a little right angle square here. It's perpendicular to the solid barrier. And theta I, which is the angle of incidence, and theta r, the angle of reflection, are the same. Okay? And so this angle here, this is theta I, because this is the incident wavefront. And this angle here, theta r, they are the same, okay, because this is the reflected wavelength. Okay, these are the same. But what if we do this edge, okay? Now here's the thing, we have to do the same amount of time to figure out where this wave is going to go, because sometimes with reflection, like, is it flipped or is it off a solid barrier, a fixed end, or a soft end? It's tough to always tell. That was a terrible line. And so how we measure this is these lines have to be the same length total, okay? And so that way we know, because we could just keep this line going here, and then we've got this wave like this, but this doesn't make any sense, right? So we can't just make up how long we want these lines to be, okay? We need these two purple lines together to be the same total length that the two red lines are. And this is about right. And you can imagine that it's going to bounce off kind of like this, as long as these angles are the same. That's kind of what we're going for. Okay, and so once again, we've got, I should do some purple. We've got theta I equal to theta R. Okay, so the angle of incidence, once again, I'm just really highlighting, theta I is always equal to the angle of reflection, theta R. Okay, that's the big idea. And you're going to have to do this in the first assignment. You're going to have to draw the incident wave ray, the incident reflected ray. You're going to have to do three of them. Okay, you're going to have to draw the normal line, right? You're going to have to draw the reflected wave ray, wave front, sorry. So you're going to have to draw all those things. So I want to see all of this just like this. Okay, that's it for that video. If you're watching on YouTube, you still should be seeing me do this because Cami didn't work for you. And I'm kind of guilting you because, I don't know, I guess it's not your fault. It's not your fault. We're going to move to circular rays. No, cancel. Here we go. All right. With a circular wavefront, when it hits the solid barrier, it kind of looks like this. So just going to delete this and clear the waves, and let's add a wall and make it bigger. This works so much better on a computer than an iPad. Okay, and let's clear the waves. Now we make a circular wavefront, boom, just like that. Super clear. It looks like whatever part of the circle was there got cut off, right, and reflected back. And so we take whatever part we're missing and we just flip it across the axis, okay? And so when it hits this, we'll just kind of try to draw that, is whatever part of the circle is there, whatever was supposed to be here is going to be reflected back here. Okay, now those should be the same. Now that's pretty weak, but here's where we should really draw it. Kind of drew it at the wrong spot. I draw the dotted line here. It should be here. I'll just erase this. This is garbage. Okay, that's what it should look like. This is a terrible drawing. It's supposed to look something like this. Okay, this is a much better job of demonstrating what should happen. Okay, just for the sake of curiosity, if you let this go a little further, you see here how the wave that went past kind of created these little circles, and that's pretty cool. That's just worth watching, and then that creates all kinds of reflections, and it gets this pretty cool stuff. But we're not going to focus on that. All we're going to focus on is this initial wave, this one, okay, that it reflects, and it's basically whatever's gone is reflected, just like a circle. That's it. Okay, now I'm going to get ready for the next video, which I should have done before the last video. Add parabola. I actually want to show that on the video. Okay, last video here. Okay, to get a parabola on this ripple tank. So now we're thinking, what's going to happen when we see things going to parabola? So I'm going to go here. I'm going to add a parabola. I'm just going to make it nice and big. And do you notice when you put your mouse over this, you see this dot here, that cross? Pay attention to that point. Okay, so I'm going to try to move this. This is finicky. My goodness. Come on. No. We're right there. It's over here. Okay. Clear the waves, and we're going to get a line source because this is what we were asked for. Okay, so this is asking for a straight wave reflected from a parabolic reflector. Okay, and so let's watch what happens. This is pretty cool here. Okay, I'm going to clear the waves. We're going to watch again. Okay, now we're going to watch in 3D. This is really going to highlight what's going on here. This is just crazy. It's so tall, you can't get behind it. Look how insane that's happening right there. And so let's stop it again, clear it. You see that point right in the middle that is just firing up. And so what is happening is all of the wave is getting reflected to the same location. So let's watch one more time. Okay, it's hitting, and you see some wave is coming back in. The wave from here is coming back in. And right there, they all combined at one location at one time, and it just fires up. Okay, and as time goes, there's more of those locations that get really increased. But let's draw exactly what's happening. Okay, and so, and that point, by the way, is happening. If you click on this parabola, it's happening right at that dot. Okay, to clear the waves, we're going to get a huge wave right at that dot. That's the center, and we call that a focal point. Okay, that's the center of all the action. And so what's going to happen if we draw a wave rays is these waves come in and then bounce off. Okay, and this one's going to come in and bounce straight back. Okay, this wave is going to come in and bounce off. And I don't really care where you put the line. Let's put the line here. It's going to come in and it's going to bounce off that curve right till there. Okay, I just missed it there, but The point is, they all bounce to the same location, and that location is going to have a huge splash. So if you get straight waves coming into a parabolic reflector, you're going to get a focal point. Okay, and so we call this, I'll do that in purple, the focus point or focal point. And so that's a big deal. We've got this focal point. This is a nice simulation of exactly what that looks like. Okay, the wave front here is this straight line. The wave front moves and hits, and here it hit and it's starting to rebound. You get the smaller parabola, right? You see that these are all the same total length, and now these are all the same length, and they all are focused in this one spot, and then they keep going past. Okay, so it's in this order here, here, the wave is coming down and then reflecting off all the different parts of the parabola and then at one point at one time. Now that's crazy. And so you get this huge right out of the water. Now what would happen if you create a wave at the focal point? So what I'm going to do is I'm going to get rid of this line here. I'm going to look here and try to find the focal point. Okay, it's right there. Now I'm just going to create a wave right there. Splash. Oh, come on, what's going on? Right here. Now look what you see. This, I can't get right on it. I'm not sure what's going on, but you get this straight wave coming out. That is so cool. And so if you can find the focal point, it's not anywhere. If I go over here and I make this wave, it's not going to be so straight. It's kind of curved, it's wonky, but the closer you get to the focal point, the more straight. It's a completely straight wave. If you can get right at the focal point, you get a straight wave coming out. That's pretty cool. And so the reason that is because it's the exact opposite, right? You just watch this in reverse. You create a circular point, it's going to be a circle, it's going to go out, it's going to hit its parabola at these points, and we're going to have the same distance line coming out. You just watch this from reverse. Starting here, you create this wave, it goes out, hits the parabola, and it shoots out. And so all these lines are equal distance, and you get the straight wave coming out. And so if we draw that in our notes, it looks like this. The wave comes here, and then it comes out. And this wave comes out till there. And this wave comes out till there. It's traveled a bit longer, so this line is a little bit shorter, right? And you get a straight wavelength coming out. If you can go from the focal point, if you generate circular waves at the focal point, that's what you see. Super cool. All right, YouTubers, make sure you hit like and subscribe because that was an awesome video.